Hey everyone! In today's video, we are going to solve LeetCode problem number 2, which is add two numbers. Here's the problem statement. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. Let me explain it with an example. Let's say we have two linked lists. The first one is 2, 4, 3, and the second one is 5, 6, 4. So the first node is the digit at ones place in the number, the second node is the digit at tens place, and the third node is at hundreds place. Similarly, for the second list, we have 5 at ones place, 6 at tens place, and 4 at hundreds place. So the numbers are 3, 4, 2, and 4, 6, 5. Now let's add them using the elementary school method where we used to carry over while adding. So we get 2 plus 5 equals 7, 6 plus 4 is 10, so we write down 0 at tens place and carry over 1, and this adds up to 8. So the sum is 807, which is stored in the linked list as 708 in the reverse order. If we code the solution using this approach, we will not need to reverse the list. It will already be in the reverse order because we will add digit at ones place to the list first, followed by tens, hundreds, and so on. Alright, let's implement this in Java. We are given the list node class in LeetCode, which has a val which holds the value of the node and a pointer to the next node. First, we need to create a dummy list node with any value. Here I'm using 0. This node is created to avoid any null pointer exceptions or edge cases when adding the first node to the list. It will just act as a placeholder for the result linked list. Now, for instance, if you don't create the dummy node, then in your logic you'll also need to handle extra conditions which will make your code more complex. For example, if result list is null, then set the head. Otherwise, attach the new node to the tail. Whereas we eliminate the extra work by simply creating a dummy node and adding a pointer to build the list. And lastly, return dummy.next, which is the entire list, skipping the dummy node we created initially. Next, we create a pointer called current to build the new linked list. And we create a new int variable carry with an initial value of 0. Next, we loop through both the input lists until both are empty. Start with the carry from the previous edition. We check if L1 has a node and add its value to the sum. And we move to the next node in L1. Similarly for L2, if it has a node, add it to the sum and move to the next node. Next, we have to calculate the carry, which will be sum divided by 10. For example, if sum is 13, 13 divided by 10 is 1.3, but as carry is an int, the value stored will be 1. And we want to store the remainder digit to the result list, and we can use a mod operator for it. So we assign a new list node with the value sum mod 10 to current.next. Once that's done, we move the pointer to the next node. After the while loop terminates, one last condition we'll need to check is if carry is greater than 0. If it is, we need to add it as a new node to current.next. Lastly, we return dummy.next. Let's check if it compiles and runs successfully in LeetCode. There we go. Since we traverse both linked lists once, the time complexity is O max mn, where m is the length of the first list and n is the length of the second list. This means the runtime depends on the longer of the two lists. And it's the same for space complexity. That's it for today's video. See you in the next one.